All right, hello everyone. Professor Dustin here. This video is going to introduce you on how to set up the first observations for your supernovas to actually start taking data on these things. So I'm going to send you over sources, a selection of sources from which you can pick and determine what the best option, which one is the best to chase after. So let me just give you a little bit of the background of what I'm going to be doing. I'm going to be getting reports in my inbox that look like this. This one's actually kind of small. Normally there's like 20 options, but basically this was last night, 7:05 p.m., 15 hours ago. There were new transients reported, 1, 2, 3, 4, well, at 8 or something of them. They say discovery date was the 27th because that's when they were discovered. Now, some of them are a little earlier, a little bit later, but that's when they were discovered. They give brightness and a position and not much else. And then like a generic sort of tag. This is just in 2023, and then they're just counting alphabetically. So there's no real information here besides like, ooh, new dot in the sky. Now, these are completely unclassified. They have no idea what these things are. All they know is that they are new dots. For these ones, there's another set down here, which is new classification. So these ones have actually been classified. You can see that they actually were discovered, pretty recently. Do we have a specific? So they were in 2023, but actually that's the time received. That's when the classification happened, not when the discovery happened. So the advantage of these classifications, you can see the classifications here. These tell you what kind of supernova they are. Now up here, these are just new dots in the sky. They could be supernova, they could be new variable stars, it could be a variety of other things. Down here, we've actually determined what kind of object they are. These are all supernova of different types. Now, it so happens that for us, we care about supernova 1A. Now, we haven't talked much about the science there, but it is true that the thing we really care about are supernova 1A. So that's nice to have these new classifications. So what I'm going to do is I'm going to select like 3 or 4 of these sources and send them over to you. And your job is to select from those 3 or 4 sources, one to look at for the next 2 or 3 weeks. So I've already done that. I've picked 3, but I wanted to show you a little bit how I picked them so you have some information. I'm going to look for brightness, and I'm going to look for whether you can see the source as distinct from the galaxy the source is in. So let's look at them. So here's clicking on these links, take you out to sources here. So this is the transient name server. This is where all the sources go, where the alerts go to the astronomical community. Here's an image before. These images are all before the supernova. So there's no supernova dots in these images. What these images are they show the actual galaxies. And you can see the X is right where the supernova is. So in this case, I think the supernova is distinct enough from the galaxy that we're going to be able to tell where the dot is appearing. So this is why I'm picking this guy. I'm going to pick this guy. Again, very, very small galaxy, but the dot does seem to be distinct from where the galaxy is. And same here. This one's a little bit trickier. You can see it's actually closer to the nucleus, but I didn't have a lot of other options. So this is, I'm hoping to be another optional one. Some of the ones that I considered and rejected was this one. So this one's interesting because super bright galaxy, right? I mean, this galaxy is very obvious, but the new source is at the same location as a previous source. You see there's a dot there. So that's likely a misidentification. It's probably an existing source, which is not actually going nova. It's probably in some kind of flare up. CV stars do this, other stars do this. So the fact that it's there suggests that it's not a supernova 1A, which is actually what we care about, which is too bad because it's a very pretty little galaxy. This guy, I think, is too close to the nucleus. You can see that the galaxy is small and bright, and I think the cross is too close to the center, so we wouldn't be able to just distinguish it from the other, from the galaxy. This guy, same deal. I think it's too close. Now, between this one and the earlier one, I don't know. Who knows? But I do think this guy's a little bit too close too. And then here, there's no galaxy in this image at all. So that doesn't mean that this is not a supernova, but it does lend itself to not being a supernova. It's, supernovas happen in galaxies. And if normally we see both the galaxy and the supernova, if we see nothing, either it's a supernova in our own galaxy, which is incredibly rare. They happen once every like 10 years. So that's really unlikely. More likely, this is just a misidentification. Now, these people are saying it's a supernova 1A, kind of interesting. It's incredibly dim, whatever, not a good source for us. So anyway, I've selected these 3 sources up here that we're going to use. So going over to the source, the observation procedures, going to the checking visibility step. This is what you guys have been doing so far. And I'm going to go through now with these 3 sources. So I'm going to go over to star alt. And what I'm going to do is I'm going to check all 3 sources at once for each observatory. So this is going to be a little bit nasty. I think it's easier to do all 3 at once than to do it like 3 times for 3 observatories, but I'm going to try to do it. One thing you have to do is you have to type in the names of the sources. So CQL, and what I'm doing is I'm naming the sources up here just based on the name. So CQL, CNC, and CJU are going to be my three names. Yeah, okay, ATSN, I should maybe use those. Whatever, doesn't matter too much. Okay, so I'm going to go over there to the CQL, grab the RA and DEC. I'm cutting and pasting it right into there. Hopefully that's enough. It might get a little grumpy if there's too much information in there. I'm just going to try it. CNC, same deal. Grab the RA and DEC. And then CJU, go over there, grab the RA and DEC there. Okay, so now I should get three different sources in my star alt map that you're used to looking at. Now I need to go to the three different observatories. What I'm going to do is I'm going to fill out this spreadsheet. So I'm going to fill out this S&E source spreadsheet for each observatory. So let me just start with one. Let's start with Australia, and the sheet happens to be alphabetical. So Siding Spring. So go over to the observatory visibility, go to Siding Spring. Right there in Australia. Everything else we should be able to be set. Let's click retrieve and see if our coordinates work. Cool, our coordinates work, and actually all the sources are miserable. Okay, so you can see that here's the moon, here's one source right there, here's one source right there, here's one source right there. You can see they're labeled 1, 2, and 3. It gives you the names of the sources I entered. Of course, I entered those random names, so if you can keep the name straight, it's on you, but it was easy to just type the 3-letter designation there. Okay, so none of these are good, but I'm going to go into that spreadsheet and show you what you would enter. And hopefully when I go to the other observatory, some of these will actually work. Okay, so I did that into the coordinates of the target, click retrieve. I want sources that are over 30 and 90 degrees from the moon. If you find a source which satisfies, make note of it. I'm going to change the language here. You always want to enter it. So just to keep data on stuff. So I'm going to click the S&E source selection spreadsheet so you can see what I'm interested in entering. So we have a whole bunch of tabs down here. Stick to this S&E selection list, 2023 to question mark. That's what we're working on now. First column here should be the discovery link. So what I'm going to do is I'm just going to cut and paste that link, smack it into there, make a line for each of them. I got to enter the discovery date. This is to make sure that we can keep track of things. So the first one, the discovery date was 2/22. Second one, the discovery date was 2/24. It's actually, that's kind of depressing. These are a little bit too far in the past for me to be too excited about them. 2/21, but sometimes we can't have that. So, okay, so I'm looking at Siding Springs, and what I'm seeing is for the first source, I mean, none of these are observable. None of them are even above 30 degrees after or before the horizon. So I don't feel any need to put anything into there except for NA. Or maybe dashes would be better. I don't really care. Something that says, no, those are not observable at all. So let's go to Sierra Tuolo and see if this one is any better. Where are you? These are like not alphabetical. It's always very kind of frustrating. Yeah, see, oh, Cerro. Aha, I spelled it wrong. Let's just change that so that I'm not driving myself crazy. Okay, so put in Cerro Tuolo Observatory in Chile, retrieve. Oof, still not very good. And of course, that's because they're all in the Southern Hemisphere. So in the Southern Hemisphere, basically, there's nothing we can see. So again, nothing there. ... Let's go back up to Utah, try again. And for Utah, I actually put observed Apache Point. Notice that for Utah, we're going to use Apache Point, New Mexico. It's close enough, doesn't really matter. Retrieve, okay, much better. So notice that what we want is we want the over 30 degrees highest in the sky, and we want over 90 degrees from the moon. But I'm going to record all the stuff that I see, which is actually above 30 degrees, just as an illustration. So for the first one, first source is this middle one. It's above 30 degrees from 21 to, well, to sunset, right? So all the way before the transit line. So 21 to sunset. And then in parentheses, notice what is being set up here. When is the object above 30 degrees and when does it transit? So it's above 30 degrees from 2100 to sunset, and it transits. Transit is the highest point. It transits at just about 2:30, right? So right in between 2 and 3. You don't have to be very accurate with this. It's just a rough estimate. And of course, if you really want to be careful, you should do 2:30, but whatever. Okay, so that's the first source. But I'm also going to note my initials, moon 64 degrees, so 60 degrees. So that does not satisfy our conditions of observability, but we should at least record it in case that's the optimal source to use for the moment. So source 2, you can see, is above 30 degrees from sunrise until 2300 or so. So sunrise to 2300, and it transits at the earliest time, right? You can see that it was the highest in the sky actually before sunrise. Normally transit actually has to be the single highest point, so transit actually happened during the day, but for our purposes, doesn't matter. Highest in the sky is sunrise right there. Okay, 26 degrees. The moon is 26 degrees away from there, so I should write CLD moon 26. Okay, another possibly not great source. Third one, you can see it actually rises, crosses 30 degrees at 4 o'clock until sunset is when it's observable. So sunset till, 0400 to sunset. And the transit is actually at sunset. Check the moon on that one. The moon is at 130 degrees. Okay, so that's interesting because that is actually better. CLD. So now we have to decide between these three, looking at the data I have in front of me, what source I want to chase. Now, of course, we could bail and we could do a different day and just say none of these sources are good enough for us to look at. But for the purposes of training, I'm going to pick a source. And, the thing is that I'm sort of torn between these two cases. This one is way more observable, way more time to look at it. This one is a very short period of time because let me just verify that again. At 4 o'clock, it's above 30 degrees. So that's true. The moon is in a really great place in that one. Oh man, I'm torn. Okay, I'm going to do the third one. I'm going to say go with this one. So notice what I did is I filled out my notes, meaning anything I thought was a matter of importance for deciding which observatory I'm going to use, which source I'm going to use. So I included my initials so I know who's doing this, where the moon is, and then I said, let's do this one. So I'm not going to do those two. I'm going to do this one. So now I can go over to the telescope to use. It has to be Utah because that's the only one that's actually observable. The other three were not possible. Exposure information. We haven't talked much about this, but I think we're going to start with is 2 times 300 bin 2. So what that means is 2 300-second exposures with 2 binning. So 2 binning means that every 2 pixels you actually stick into 1 pixel. So it increases the sensitivity, but it decreases the resolution. But that's actually what we want for our project. We don't care about resolution. What we care about is sensitivity. So I'm going to do Utah. So now I'm going to go over to the Utah telescopes. That's all the T15, all these guys. So I should actually check to make sure which ones in Utah are going to be the ones we actually want to use. So that's back on the observation procedure sheet down here, Utah, T5, 21, and T11. So what I'm going to do is I'm going to look for reservation time on T21 and T11 to decide which one I want to use. So let's do 11 first. Because we want to make sure that we actually have time available on these telescopes. And there's lots of time available because the moon is up and people aren't super interested in like doing observations. And so you can see either in the time actually interested, and there's lots of time. So there's definitely T11 works. Let's check out T21 as well. Lots of time there too. So I happen to know that T21 performs a little bit better than T11. So I'm going to just pick T21 kind of arbitrarily and go to, so the next thing on my list is that once we've picked the source, done the source selection, this is alternative procedure, so you can skip that. So now we go down to planning and monitoring the observations. Here's the list of telescopes. I've selected the list pretty well. This video is going to be the video I'm making right now, an updated version, so you can forget about that. Okay, so we want to go to the deep sky plan and correction section of the iTelescope website, name the file source, whatever you like, and put in the coordinates. So I'm going to go to T11, going to go deep sky objects, plan file name. We have to make sure that I know which source I'm going to actually follow. It's source 3. So I'm actually going to, that's CJU. I'm going to get rid of all of the rest of these so that I do not get myself confused. So now the only source I'm looking at is CJU. It happens to be this guy. So I'm going to name it exactly the name that's up there. SN 2023. Probably get rid of all the spaces just in case it matters. CJU. Cool. Target, again, just name it the exact same thing, 2023 CJU. Copy and paste the right ascension declination right into that. You guys have now had some experience using the right ascension declination. You can see that iTelescope does advise like a certain format. Make sure to keep the format. I always get a little bit worried about whether you need to keep all the decimal places. Normally, I actually just get rid of all the decimal places. So this just ends with like that. I haven't had trouble with that. We should maybe, check that at a later point. But okay, so actually, you can interesting. This is the maximum above the horizon is 15, so maybe we go a little earlier. But we do want to miss the moon. So okay, right ascension declination. This all looks fine. I'm going to do 2. And then I want to do the filters that are listed in the supernova observation plans. For the filters, we want at least the bluest B and the reddest V or I. So we kind of want to skip V. So we want to do B and we want to do either I or R. So first set this to B, 300, binning 2. So that's 2 filters. 2 exposures, filter B, duration 300 seconds. Quantity 2. The reddest is going to be R. Oh, we have R and I. So in this case, you kind of have choices, but let's just stick with R, 300 and binning 2. So that's our observation set. Now it says this thing about repeat instead of doing numbers, whatever. It doesn't really matter for our purposes. That should be good. Try to do exposure billing always because it will always be cheaper, but if it reverts back to session, don't worry about it much now. And now I just want to make sure there's no advanced options. I think there isn't. Yeah, plate solve takes a lot of time, so we don't want to do that. So at the moment, there's no advanced options. We should be able to just do this. Okay, great plan for later. Plan saved. So let's go back over to the observations and check to make sure we're doing the right thing. Binning exposure times, you can see binning 2 is advised. We've had luck 2 times 300 or 3 times 180. Once the observation plan is set, reserve time. So I'm going to reserve time by going over to make a reservation. And notice that I want to match the time observed with the source selection reservability, which is now between 4 and sunset. And it gets higher and higher and higher. So later in principle should be better, although I want to make sure I avoid the sun at all costs. So what I'm going to do is I'm going to get out of the way of the moon and just do like right there. So reserve about an hour. 300 seconds is 5 minutes. I have 20 minutes of exposure time. The device is 1.5 times as long as the total exposure times, but normally I find that just like making an hour is good enough. So start time, end time, select a plan to run. Where was it? CJU, right? Reschedule. I kind of always click reschedule, sort of no matter what. Oh, sorry. I'm doing this too early in the morning. I'm doing it on the wrong day. You can see that actually that day is in the past. So that was February 28th. Today is Wednesday, March 1st. So I actually have to do Wednesday, March 1st. Cool. I missed it. Let's just make that go back to 4 o'clock. Select the plan, CJU. Always reschedule just because that's safest. Confirm reservation, and we should be good to go. So now let's go back and check the observation plans. We want data for as many as the 28 days as possible. The observer can decide how to manage that. So this is now the procedure that I would use. We're now at this step 1 right here. Reserve around 5 days immediately with 60-minute reservations. So the idea being like you want to set aside, if you're going to decide to use the telescope, you want to set aside a certain amount of time. My recommendation is 5 days. That's what's indicated by the procedure. So let's go in here and write there. And I will probably cut this part of the video or fast forward it, but I'm just going to be selecting plans. still clicking reschedule no matter what, because why not? Okay, so that was reserving 5 days. Notice that my last few days are actually running into the moon. That is not great. Eventually, I'm going to have to check to see where the moon is in the position relative to my supernova. So the moon is definitely going to get in the way, but there's nothing we can do about that. Now, we may be able to shift the observation time to a different time later in the 2 or 3 weeks when the source is up. But for the moment, I have nothing else to do. So I've got my 5 days. What's the next order in my observation procedure? That's it. Check after the first night. So this step is done. So we have now set up observations for 5 days. After one night, we're going to have to check again to make sure that we actually see the source that we were looking for. Let me go up and see if I've filled out my spreadsheet. You can see when the first observation is set, enter this information. I did that. UT, I should actually put the filters, U and R. Actually, I did B and R. And then notice that the next column is notes from before or after first observation. So if I had anything else I wanted to say, like I should write like moon is getting worse, for instance, so that we're aware that the moon needs to be taken care of. But I haven't done the observations yet, so anything further in this column I shouldn't have to deal with, and we are now ready to simply wait. Okay, so this has been an introduction to the first night of iTelescope observations for the supernova project. I hope it has been helpful, and obviously send me any questions as you go, but we have nothing to do now but wait and hope the observations were taking at least one of those first 5 days. Great, thanks very much. Later, guys.